Hi everyone, this is Module 10. Today we're going to be talking about physical activity and I apologize there's not a picture, but basically what you do is you pinch the subcutaneous fat, the fat underlying the skin, and then using a device called a caliper you measure how much fat there is in that pinched fold. Bod pod is the picture that you see in the top right hand corner. What this does is it measures air displacement. So the amount of space that an individual takes up is proportional to their body fat percentage. Hydrostatic weighing is based on a similar principle, only it's based on water displacement as opposed to air. You see that picture in the bottom left. Bioelectrical impedance is this device that just popped up on the screen on the bottom. And this is a handheld bioelectrical impedance device. There are also scales. It looks like a scale that does this as well, but what it does is it sends a very small electrical current. You can't feel it, but it sends that current through the body. Through the handheld one, it would send it from one hand to the other, and it measures the amount of resistance that that current faces as it travels. And that resistance is proportional to the body fat percentage. And then probably the best, gold standard, the best way to measure body fat percentage is to use DEXA. This is the picture that you see on the top left. Is an individual being scanned by DEXA. DEXA is dual X-ray absorptiometry. It was first used to assess bone density, like to diagnose osteoporosis and so forth. But it's also been effectively used to measure body fat percentage. So next let's talk about how does one become overweight or obese. On a very simple level, if energy in, meaning what you eat, is greater than energy out, then you're going to gain weight. And if you burn more calories than you consume, you're going to lose weight. However, I think you're probably all aware that it's more complex than that. There are genetic, behavioral, environmental factors, physiological, psychological, hormonal, social, cultural, and probably many more that aren't even listed, that all relate to how much food we eat, what types of food we eat, and how active we are. What kind of job we have, what our culture is like, do we live in a safe environment where kids can be outside, and so on and so forth. All of those things and many, many more contribute to obesity. Next, let's talk about the prevalence of obesity and overweight. The prevalence has, of course, increased dramatically. This is particularly true since the 1970s. 31% of men and 33% of women in the United States are considered to be obese. This is based on classification by a BMI greater than 30. And if you consider overweight to be a BMI greater than 25 and obese to be a BMI greater than 30, then 71% of men and 62% of women, they meet one of those two classifications. So nearly 2/3 of U.S. adults. Particularly alarming is the increasing prevalence in children. And then one more statistic to point out to you is that the average adult gains somewhere between 1 and 2 pounds a year after the age of 25. So that may sound fairly small, but if you consider that someone from age 25 to 50 would gain somewhere between 25 and 50 pounds, obviously that's a considerable amount of weight gain and would put someone easily into an overweight or obese category. So the Centers for Disease Control is headquartered in Atlanta, and one of the things that they do is they keep track of all kinds of health information for the United States, and they do this by state as well. So I pulled this straight off of the CDC website, which is cdc.gov. And this is data for Alabama on the percentage of adults who are obese, who are overweight, and so forth. And so you can see that 33.5% of Alabama adults are considered to be obese. 33.4% are overweight, so that means 1/3 are obese, 1/3 are overweight, so that means that only 1/3 of Alabamans are normal weight. And that data comes from the BRFS, which you have learned about in this class. That's the phone call surveillance system. And then you can see for adolescents, about 17% of Alabama adolescents are obese, about 16% are overweight, and then children, it's about 15% of 2 to 4-year-olds, and about 16% of 2 to 4-year-olds are overweight. So this is a problem not just in adulthood, but in childhood and adolescence as well. This is looking at the entire United States. This is also CDC data, and this is a prevalence map. So the green are the states where obesity prevalence is somewhere between 20 and 25%, and then the darker the color, the higher the percentage. So you can see that Louisiana, Mississippi, Alabama, and West Virginia are the 4 states where the prevalence of obesity in 2015 was greater than 35%. So to summarize the most recent BRFS data on obesity in the United States, no state had a prevalence less than 20%. 6 states, and then DC as well, had a prevalence somewhere between 20 and 25%. 19 states, as well as Puerto Rico, had a prevalence of obesity between 25 and 30%. 21 states and Guam had a prevalence between 30 and 35%, and then 4 states that we mentioned previously had prevalence of obesity of 35% or more. And these numbers just seem to be climbing every year. So of course this begs the question, what can we do about this? How can we either help people lose weight or prevent them from gaining too much weight? Body weight appears to be regulated around a set point or a set number, and this is called the set point theory. This is somewhat disputed, but there's a lot of evidence to suggest that this is true. And there are 3 components to how much energy you expend, or how many calories you burn. The first is the resting metabolic rate. So when people talk about metabolism, this is probably what that means. The term metabolism, when used by just the general population, is pretty hard to define. But about 60 to 75% of the calories that are burned by an individual in a day are simply to keep them alive. Like if they did nothing, if they did not move at all, ate nothing, moved not at all, they would still burn somewhere in the neighborhood of 12 to 1500 calories to keep all of their metabolic processes going. That's the resting metabolic rate, the number of calories you need to stay alive. Then there are other additional components of energy expenditure. There's the thermic effect of a meal, or sometimes this is called the thermic effect of feeding. This is the calories that you burn to digest, transport, and break down food. This is about 10%. So if you assume a 2,000 calorie diet, that means that every day you burn about 200 calories digesting and breaking down food. And then the one that we have the most control over is the thermic effect of activity. This is the energy above your metabolic rate that's needed to perform whatever activities you're involved in. So this is somewhere between 15 and 30% of daily energy expenditure. So again, based on a 2,000 calorie diet, somewhere between 250 and 500 calories a day would be the thermic effect of activity. Problems, including respiratory problems like sleep apnea. This is when you stop breathing while sleeping for, usually it's a few seconds, and that can be very dangerous. You have polycythemia, which is basically when your body produces more red blood cells. It makes your blood thicker, which sounds potentially not problematic, but what it does is thick, viscous blood can't flow very well, and it can result in clotting. A thrombosis is a blood clot, and those clots can be very dangerous because they can travel to the lungs or the brain and rupture, and those can be fatal. Obesity is actually associated with a hypertrophic cardiomyopathy. This is an enlarged heart. It makes the heart work so hard that it becomes pathologic, meaning a disease state, and can be very dangerous. Obesity is associated with congestive heart failure, and then also decreased exercise tolerance, which makes all of these other problems worse, and so really is a vicious. So what I want to spend the rest of the time talking about is weight loss. A lot of times with talks about obesity, there's all this information about just what is obesity and, eat less, exercise more. Well, we're going to talk a little bit about that, but I want to be a little more specific about it. So this is data showing typically what happens with weight loss with a low-calorie diet, which is how most people lose weight. Self-help is just people doing whatever they wanted to try to lose weight. Commercial was Weight Watchers. And then there was another study that looked at what they called placebo plus lifestyle. So they gave them a pill that they told them would help them lose weight, but it was actually a placebo, a fake pill. And then they had them eat less food and be physically active. And so you see that with the with the self-help program, the people lost about 2 kilograms. That's around 4 or 5 pounds. And they regained it within a couple of years, 100 weeks. With the commercial study, they lost about 7 kilograms on average, which is about 15 pounds. And they regained a lot of it after a couple of years. With the placebo and lifestyle study, they lost a similar amount of weight. It took longer to regain weight, but they did regain it within 4 or 5 years. So the point here is, yes, weight loss can happen. It's very hard to keep weight off in the long run. Very, very difficult. So let's talk about what happens to our bodies with a low-calorie diet. The study that I picked to use as an example is from this Biosphere 2. This is a research facility in Tucson, Arizona, and there's a picture of it on your screen. It's a really cool concept. What they did is they built this giant system, and they wanted to study soil and animals and all kinds of conservation within this closed system. And from 1991 to 1993, what they did is they let these individuals, about 12 people, live inside this system, and they were scientists, and they were going to study all kinds of, I don't even know what they were going to study, honestly. It kind of became its own study in and of itself, because what happened is that it turns out there was this low food supply. These people were supposed to live off the land and study all these animals and soil and plants, but there was a very low food supply. And so what happens when there's low food supply? People eat. So this is from the Biosphere study. They studied 3 male Biosphereans and 2 females. And so what you're looking at here is control subjects who were people who didn't go into the Biosphere. And then the Biosphereans, 1 week after they left, eventually they had to remove the Biosphereans because the food supply was so low. So they measured all these outcomes a week after they left the Biosphere and 6 months after. And so you can see the body weight of the controls, 68 kilograms. A week after exit, the Biosphereans were down about 9 kilograms. That's close to 20 pounds. And then they regained that weight 6 months after they left. So they came out of the Biosphere, they were exposed to normal food supply, and they regained the weight. But let's look at the percentage of body fat. Okay, so 1 week after exit, this is highlighted in green on your screen, they had about 10% body fat. That's very low, especially for females. 6 months after exit, they were back up to around 21% body fat, which is more typical. what I really want you to notice is the metabolic rate. So the metabolic rate in control subjects was about 5,900 kilojoules per day. Don't worry about exactly what that means, just look at the changes. 1 week after exit from the biosphere, the biospherians, they were about 5,400, and then 6 months after exit, they were about 5,800. So there was a difference after the 6 months of about 400 kilojoules per day. So what this means is that the biospherians, they lost a lot of weight and their metabolic rate went down, meaning they were burning fewer calories to stay alive. So I want you to think about why that might happen. Why would God make us this way? I think the reason is that people exposed to starvation, which historically has happened a lot. It doesn't happen much in the United States anymore, but it happens around the world still today. If people are exposed to low levels of food supply, their body's response is to essentially slow down its metabolism. It prevents people from dying of starvation, or it prolongs their life in low food supply situations. And so that's what I think happens, and that's what happened here. So the question is, how can we help people lose weight using this information? Does exercise and calorie restriction help people lose weight? Yes. You saw that the Weight Watchers and even the self-help and the placebo lifestyle study, all of those helped people lose weight. The more difficult question is whether it helps them keep weight off in the long term. And so I really want us to key in on this idea of metabolic rate. All right, so we're going to look at metabolic rate. What we saw in the biosphere study is that the biospherians, after they lost weight, their metabolic rate went down. That's what we see here. In this study, they looked at people who were what they call formerly obese, so people who had lost weight, and controls, people who had never been overweight and had never lost it. And what you see here is the formerly obese people, the people who had lost weight, had about a 5% lower metabolic rate than the controls. What happens is that weight loss induces or causes metabolic rate to go down. This may predispose people to obesity. Think about it. If your metabolic rate goes down, you're not burning as many calories to stay alive, and therefore that favors gaining weight back. Another important concept is that it seems like there are differences in the way individual people respond to weight loss. So this study, what they did is they looked at resting metabolic rate after 5 weeks of weight loss. And so each bar represents a different person. So you can see on the left, there's about 8 people whose metabolic rate actually increased after weight loss. There were about 4 people whose metabolic rate stayed the same, and there were another 8 or so people whose metabolic rate went down. So this suggests that maybe everybody responds differently. Maybe we're genetically programmed, some of us, to decrease metabolic rate or not, or increase it even after we lose weight. It's also possible that the method of weight loss is important. Can we help ourselves or help others who want to lose weight and keep it off? Can we help them by helping them lose weight in an appropriate manner? So what this study did is it looked at 2 different types of weight loss: a medical treatment, which involved exercise and dieting, and a group that lost weight by bariatric surgery. And so I've highlighted the parts I want you to focus on in red. So look at the metabolic rate. In group 1, the medical treatment group, what the metabolic rate before the weight loss was about, let's say it's about 2,300 calories. That's how many calories they were burning in a 24-hour period. After 6 months, it was down to 2,051. So it did drop off, but actually that difference is not statistically different. In the bariatric surgery group, the metabolic rate before surgery was about 2,400 calories. After, it was about 2,100, and that asterisk that you see there means that that was a significant decrease. So what this showed is that the bariatric surgery resulted in a decreased metabolic rate, but the medical treatment didn't. So perhaps the way we lose weight is important. Here's another study that suggests that's true. This study, they looked at people who lost weight, and then they followed them up 3.5 years later. And the group who lost weight just by changing their diet, the metabolic rate was about 18% lower than it was before they lost weight. And the people who lost weight by dieting and exercising, the metabolic rate was only about 10% lower. So everybody had a decrease in metabolic rate, but that drop-off was less in people who exercised also. Probably the reason is that exercise and physical activity maintains or builds muscle mass. And muscle is a tissue that is metabolically active compared to fat, meaning it burns calories. Okay, so if you can maintain or increase your muscle mass as you lose weight, that is going to be incredibly important in helping you prevent your metabolic from declining. And this study gets at that concept. So the question is, does the intensity of the exercise matter? And there was a control group, a group who exercised at moderate intensity, and a group who exercised at high intensity. And so you're seeing changes in body weight, body fat, and fat-free mass. That's muscle. Okay, and so in the control group, as expected, there were no changes in any of that in weight, fat, or muscle. In the moderate group, you see that body weight decreased by about 3.5–4 kilograms. That's quite a bit, 8 to 10 pounds. Body fat decreased considerably as well, and muscle mass went up a little bit, but not statistically significantly. But in the high intensity group, body weight decreased, body fat decreased, and muscle mass went up. So likely there is a change in metabolic rate as well, which is what they looked at. This is from the same study. And so you're looking, the black bars are pre-weight loss, the gray bars are post. And so the y-axis is kcals per day. So this is essentially metabolic rate. So the moderate intensity group decreased their metabolic rate, but the high intensity group increased metabolic rate. So this suggests that the muscle mass increase does indeed result in not just a prevention of the drop in metabolic rate, but actually, in this case, it actually increased metabolic rate, which is very important in maintaining weight loss long. So in summary, obesity is a big problem in the United States as well as around the world. Weight loss is possible with calorie restriction and or exercise. However, maintaining the weight loss is much more difficult because of the decrease in metabolic rate that typically occurs with weight loss. However, building or maintaining muscle mass can prevent at least some of that decline in metabolic rate, thus making it easier to maintain weight loss in the long run. So today you have quiz 4. This will cover modules 8, 9, and 10.